Hello friends, I am Dr. Sirajul Hafizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about gases. You know friends, some terms are also important in this chapter. So I am going to explain some important term related to gaseous molecule. So let us to start with pressure. You know, pressure is the amount of force applied to an area. It is represented as P is equal to F by A with the mathematical formula. So, atmospheric pressure is the weight of air per unit of area. Now friends, Boyle's law. You know friends, the volume of a fixed quantity of gas at constant temperature is inversely proportional to the pressure. Now, as P and volume are inversely proportional, a plot of volume versus P pressure results in a curve. You can see the curve. Since PV is equal to K, so V is equal to K into 1 by P. This means a plot of volume versus 1 by P will be a straight line. Now, friend Charles' law. The volume of a fixed amount of gas at constant pressure is directly proportional to its absolute temperature. That is, V by T is equal to K. You know from this mathematical formula, a plot of V versus T will be a straight line. So look at this straight line, which is volume versus temperature. Now friends, Avogadro's law. The volume of a gas at constant temperature and pressure is directly proportional to the number of moles of the gas. Mathematically, this means V is equal to K. So observations: 2 volume hydrogens, 1 volume oxygen gives 2 volume water vapor. Explanations, and this is the equation. So ideal gas equations. Friends, so far we have seen that volume inversely proportional to 1 by P, volume directly proportional to temperature, volume directly proportional to N. So combining these, we get volume proportional to NT and P. So ideal gas equation, the constant of proportionality is known as R. the gas constant. So these are the units of ideal gas. The relationship V directly proportional to NT by P then becomes V is equal to R NT by P, then PV is equal to nRT. Densities of gases. If we divide both sides of the ideal gas equation by volume and by RT, we get N by V, P by RT. So densities of gases, we know that moles into molecular mass is equal to mass, N into capital M is equal to M. So multiplying both sides by the molecular mass capital M gives M by V, Pm by RT. Densities of gases, mass divided by volume is equal to density. So density is equal to mass by volume is equal to Pm by RT. So friends, this is notable point. One only needs to know the molecular mass, the pressure and the temperature to calculate the density of a gas. So molecular mass, we can manipulate the density equation to enable us to find the molecular mass of a gas. D is equal to Pm divided by RT, which becomes M is equal to dRT by P. So Dalton's law of partial pressure. The total pressure of a mixture of a gases equal the sum of the pressures that each would exert if it were present alone. In other words, P total is equal to P1, P2, P3 and so on. So partial pressure of gas, when one collects a gas over water, there is a water vapor mixed in with the gas. To find only the pressure of the desired gas, one must subtract the vapor pressure of water from the total pressure. So Kinetic-Molecular Theory. This is model that adds in our understanding of what happened to gas particle as environmental conditions change. So main tenets of kinetic molecular theory: gases consist of large number of molecules that are in continuous random motions. The combined volume of all the molecules of gas is negligible relative to the total volume in which the gas is contained. Attractive and repulsive forces between gas molecules are negligible. So main tenets of kinetic molecular theory: energy can be transferred between molecules during collision, but the average kinetic energy of molecules doesn't change with the time as long as the temperature of gas remains constant. Now main tenets of the kinetic theory, another point: the average kinetic energy of the molecules is proportional to the absolute temperature. So what is effusion? The escape of gas molecules through tiny holes into an evacuated space. Diffusion: the speed of one substance throughout a space or throughout a second substance. Now friend, Boltzmann distributions. Effect of molecular mass on rate of effusion and diffusion. You can see, use the slider to advance time and compare the rates of effusion of gas to gases. You can see. So what is the real gases? In the real world, the behavior of gases only conform to the ideal gas equation. at relatively high temperature and low pressure. Now, deviation from ideal behavior. The assumptions made in the kinetic molecular model break down at high pressure and or low temperature. So real gases. Correction for non-ideal behavior. The ideal gas equation can be adjusted to take these deviations from ideal behavior into account. The corrected ideal gas equation is known as the van der Waals equation. So the van der Waals equation P plus n square A divided by V square V minus NB is equal to nRT. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.